Hi everyone, in today's lesson we're going to talk about how to find limits algebraically that form horizontal asymptotes. So if I have a polynomial function, we're going to use the leading coefficient and the degree to determine the behavior as x approaches infinity or negative infinity. So if I have a positive leading coefficient, do you see here the number in front is a 1, and I have an odd degree, my power is 3. We know it resembles cubic behavior. So as x approaches infinity, so as x goes all the way to the right, where does the graph go? It looks as though the graph is headed up to infinity. So we could say the limit as x approaches infinity is infinity. Now we can say as x approaches negative infinity, so as x goes all the way to the left, where does the graph go? So as x approaches negative infinity, it looks like the graph is heading down to negative infinity. Okay? The next example, if I have an odd degree, so say power of 5, and a negative leading coefficient, so a negative 1. Again, my end behavior says as x goes to infinity and as x goes to negative infinity. So as x goes to positive infinity, it looks like the graph is headed down to negative infinity. And as x goes to negative infinity, the graph is headed up. So the graph is headed to positive infinity. All right. Now if I have another polynomial function, but except now I have an even degree and a positive leading coefficient, it looks as though as x approaches infinity and as x approaches negative infinity, both graphs of both end behaviors go up to positive infinity. So both of these limits are going to go to positive infinity. And as a negative leading coefficient, so if I have a negative out front and an even power, it looks as though they both shoot down to negative infinity. So both of these limits are going to go to negative infinity. So as x goes to infinity and as x goes to negative infinity, both go down. So in conclusion, if I have a polynomial function with a leading coefficient of positive and an even degree, it's going to model this behavior. Even degree negative coefficient is going to model this behavior, and so on and so on. All right, now let's talk about rational functions. So if I have a rational function, we're going to use horizontal asymptote rules to help us approach infinity. So the first rule to remember is if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is the ratio of the coefficients. So the degree of the numerator is 2 and the degree of the denominator is 2. The coefficient of the numerator is 3, the coefficient of the denominator is 1. So we take the ratio. So the ratio would be 3 over 1, which reduces to 3. So if you look here, that's how they got the line y equals 3. So as x approaches infinity, or as x gets really, really large, it looks as though the graph is headed to 3. And as x gets really, really small, or as x approaches negative infinity, it looks as though the graph is approaching 3. So if we didn't have this graph here, we would just say, okay, the limit as we go to infinity or negative infinity will have to be the ratio of the leading coefficients. So they're both going to go to 3. All right, rule number 2, if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is equal to the line y equals 0. So again, degree is here is a power of 1. That degree is less than the degree on the denominator, which is 2. So if that's the case, we would just, if we did not have this picture to see that they're both approaching 0, we would just look at the degrees. The degree of the numerator is less than the degree of the denominator. Therefore, the limit as x approaches negative infinity and as x approaches positive infinity looks like it's going to the line y equals 0. So this is approaching this line, the y equals 0, and this one is approaching that line, the y equals 0. All right, now let's talk about rule number 3. If the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote, and the graph will either approach positive or negative infinity. So we have a degree of the numerator being greater than the degree of the denominator. So if I want to take the limit as x approaches infinity and as x approaches negative infinity, I want to see where this graph heads. So we know that there's going to be no horizontal asymptote, and we know it's going to approach positive or negative infinity. But how can we do that? So what you want to do is you want to pick a very large number for x. So let's pick infinity, a number close to infinity, we'll say is 100. So we're going to take 100 to the fourth divided by 2 times 100 squared minus 4. We're going to plug it in, and we're going to see what happens to the numerator and see what happens to the denominator. So if I plug in the numerator, I'm going to get a negative number. Now, just like we did the other day, I don't care if it's what number it is, I just care that it's negative. Okay, now if I type in the denominator, do I get a positive number or a negative number? I'll get a positive. So when I take a negative divided by a positive, I get a negative. Therefore, the answer is negative infinity. So do you see how as x approaches positive infinity, the graph is headed down to negative infinity? All right, now let's pick a really, really small number as x goes to negative infinity. So let's just say negative 100. So you're going to want to know if the numerator is positive or negative. And the numerator will be negative, and the denominator will be positive. And a negative divided by a positive is a negative. So it will also approach negative infinity, which I can prove from here. As x approaches negative infinity, so does this graph. All right, let's look at a different example. So again, the degree of the numerator is greater than the degree in the denominator. So we know they're going to approach some sort of infinity. So let's prove it. So we're going to pick a really, really large number. So again, let's use, 100 again. So we have negative 3 times 100 squared over 3 times 100 plus 4. Now if you do the numerator, you will get a negative number. And if you take care of the denominator, you're going to get a positive number. And when you divide those two, a negative divided by a positive is a negative. So it will approach negative infinity. And let's prove it with the graph. As x approaches positive infinity, the graph is headed to negative infinity. All right, now let's try as x approaches negative infinity. I'm going to plug in a very small number. So negative 3, let's try negative 100 squared over 3 times negative 100 plus 4. So the numerator will be negative and the denominator will be negative. A negative divided by a negative is a positive, so this will approach positive infinity. And we can prove it. As x approaches negative infinity, the graph is headed up. So just to recap, if we want to see what happens as a graph approaches positive or negative infinity, and we know that it's a rational function, if it's a fraction, we're going to look at the degrees. If the degree of the numerator is equal to the degree of the denominator, then we take the ratio. If the degree of the numerator is greater than the degree of the denominator, smaller, then we are going to say the limit is y equals 0. And if the degree of the numerator is greater than the degree of the denominator, we have to plug in values and see where it approaches, positive or negative infinity. All right, jot down any questions that you might have and ask them tomorrow, and we'll see you in class. Have a good night.